Welcome to Machine Learning Lesson 2.4. In the previous lessons, we saw how we can explore the information in a data set, as well as extract information via columns and rows by filtering it out. So now we're in a point where we're looking at our data and we're trying to prepare our data for analysis or eventually for machine learning. So again, if we have bad data, it's impossible to get a good analysis or a good machine learning model. Again, it goes back to if we're going to teach a little kid the wrong thing, they're going to learn the wrong thing. And it's going to be harder for us to kind of backtrack and adjust it. So let's get to it. Let's look at our original data. So we're going with the automotive data that had the miles per gallon, the horsepower, weight. But what I've done is I've introduced a bunch of dirty data. A couple of spaces where perhaps we didn't know what the displacement was. In other cases, I put a question mark. I did NA. I did N with a lowercase a, N/A. Again, this is real world. In some cases, data entry is done by humans. And left to human error, sometimes things will get inputted the wrong way. So let's see what happens when we bring this data into our environment. Okay, so I've put the automotive dirty data on my Replit account. I'm going to bring it in. And one of the things we're going to notice immediately when we look at our data is that the computer decides to make some of these entries of NA, N/A into not a number. Now, I kind of glossed over a little bit. If you notice, I imported another library called NumPy. NumPy is a Python standard for dealing with numbers in scientific and engineering applications. It's very powerful. A lot of people use it, but we're going to use it for just one thing, and that's for this not a number constant. So when we imported the data, Pandas decided to make some of these fields that obviously are not a number into this constant. But we do also notice that it didn't do some of the other fields. But let's handle these fields for right now. So let's go down to the bottom. And let's do a little analysis of our data. So let's do df, which is our data set, is NA. And let's do a sum. Let's see how much of this dirty data we have in our data set. Okay, so we see here, based off our analysis, we have 4 entries in displacement, 1 entry in weight, and 3 entries in acceleration that are dirty, not a number. Again, that's not all their dirty data. We'll handle some of the other dirty data later. For instance, we have an NA here, we have spaces, we already saw the question mark. The computer's not picking those up as not a number. Again, it only picks up these that are actually the NumPy constant, not a number. All right, so we don't want to have to deal with dirty data. So the easiest thing for us to do, if we can, is to simply get rid of the dirty data. So I'm going to do a print of df.shape. And if you recall, df.shape gives us the number of rows and columns that we have. And now I want to do this. df equals df.drop NA. So we're going to drop all the rows that have a not a number constant in it. And we're simply going to reassign it back to our data set. So our data set becomes clean. So let's do this. Let's retype df shape. And while we're at it, let's go ahead and take a look at those first 30 again. And let's do a comparison to see what's kind of left over. Okay, so we can see here that from our original set, our first df shape, we got 398 rows. After we've dropped it and we print out the shape again, we're now to 392, which means 6 rows dropped. Now let's take a look at our data over here. So we got 4, 1, and a 3. So you might add it up. You might say, well, wait a minute. There was, 8 places where there was not a number. That might be true, but some of them might be existing on the same row. Okay, so again, you constantly want to look at your data. So let's see what happened. We had our second row, which was the Buick Skylark. It had 2 naughty number constants in it. So let's see if that still exists in our new data. You can see here, the Buick Skylark's not there. Actually, as we look at the first 30, which is not the original 30, it's the first 30 after we've dropped all the NAs, all the naughty numbers. And we can see here is that there aren't any more of those constants. But what we are seeing is we still got dirty data. We still got the question marks, we still got the spaces, we got this NA, we got this NA with a capital N. So now we got to handle those. So let's go in here and let's see what we can do with those particular ones. So if we do df, if you recall, there was a function called isIn, which allows us to kind of specify some characters. So let's look for the space. Let's look for the question mark. Let's look for the NA with a capital N. And let's look for the NA with the lowercase n. And let's do the same thing, a sum, a count. So we can see here, based off our new data, we have, 3 in cylinder, 7 in horsepower, 4 in weight. So notice there's still a lot of dirty data that we have to handle. So you know what? We can do the same thing we did before, which is to drop it. But before we do that, I want to show you something else you can kind of do to also look to see if there's any dirty data. Again, we lucked out in that we were able to kind of glance at the first 30 and find that we had some dirty data. If we do a df d types, it kind of tells us the data types for each of the columns. So we can see here that for MPG we got float 64. That means that everything in that column is a float value. But if you look at cylinder, we get something called an object, which means not everything in that column was an integer. Because if you recall, cylinders typically were 2, 4, and 8. We had a couple of instances of 3 and 5. Not sure what that's all about. Again, that might be also an indication of dirty data. The fact that we had a couple of entries with cylinders of 3 and 5. Again, we're not going to handle those in this particular video, but just realize cleaning your data is extremely important. Right now, we're just kind of touching the surface in terms of missing data. So anyway, going back to the data types, we can see here horsepower has object, weight has object, model year has object, which in all of these, we're really expecting some kind of numerical data type, whether it was integer or float. And that's kind of confirmed from our isIn, where you can see that cylinder, horsepower, weight, and model year all have one of these. All right, so we got to clean that up. So I mentioned one easy way of cleaning this up is the same way we did before. We could just simply drop it. But before we can drop it, we have to change it. So we can change it by using another function from our data frame, which is to replace. So I'm just going to scroll up and I'm going to grab all these. Go down here. And I'm going to replace them with numpy, not a number. Okay? So this was the reason for us to import numpy, so that we can use this constant in the replacement of this. So let's do that, and then let's do another df is na sum. Okay. And we can see here now the is na is actually picking up these as not a number. And let's go in and let's just take a look at that first 30 again. Okay, and now we can see here the spaces have not a number. I'm not sure what these were originally. It might have been a question mark and a space. But you can see here none of those other characters, the NA with a capital N, the NA lowercase, you don't see this. Everything got replaced with the official numpy not a number constant. Now that we have done that, we can simply drop it. So we'll do the same thing as before. Matter of fact, because I'm going to do the same thing as before, why don't I just do this? Why don't I copy it from up top? So I'm going to copy this exact same code. I'm going to scroll down. Let's paste it in here. And let's run it. Okay, so originally we had, after our first drop of NAs, we had 392. And now after our second drop of NAs, we have 378. So we've kind of gotten rid of all of our dirty data. And let's take a quick look. And sure enough, at least within the first 30, we're not seeing any more of the dirty data. So, we've reduced our data set now down by 21 or 20. I think 20, because I think we started with 398. So, that's okay. But let's say it ends up being that you end up, removing a lot of dirty data. And maybe you don't want to do that. So there are other options instead of simply dropping your dirty data. I'm not necessarily happy with the option I'm going to show you right now, but let's give it a try anyway. So I'm going to run this one. Actually, no, better yet, why don't I do this? Why don't I just simply copy this down below? Actually, let me run it. Okay, so I'm going to run this, run all these, run this one, run this one. I don't need to run that one. Let me run this one. Okay, let me run this. And now you're going to see a good reason for these code blocks. I'm not running this one. This one's dropping it. What I am going to do is I'm going to do another code block afterwards, because I want to show you something else that we can do. That instead of dropping, sometimes we can get away with simply modifying what the NAs look like. So fill NA. Fill NA will allow us to maybe provide a value. So let's say I wanted to simply fill all NAs with 0. We can do that. Or with some other number. We can do that. Again, I'm not happy about having an NA versus a 0. Again, both of them can affect your data. But what fill NA does have is a option for you to do something called forward fill. Okay, and let's take a look at our data real quick first, right here. So what forward fill lets you do is that it will take a value and replace it with the one that's in front of it. Okay, so this will fill into the 8. This will fill here. This will fill here. So let's take a look at that. All right, so we're going to fill this. And let's do another df.head of the first 30. And you can see here, this got filled with the 8. You can see here is the duplicate here. Now the data looks better. Now, is the data skewed? Yes, it is, because now we've introduced some information from the previous entry, not actually from its own entry. Again, in some cases, it's okay to fudge the numbers, especially if you have large data sets. It might be okay for you to simply forward fill, or what I'm going to show you now, backfill. So let's focus on this one here, okay? So this one was forward fill. So the forward fill put the 150 and 3,433 forward. I'm going to have to run this from the top again, so bear with me. So I'm going to import it. I'm going to do all this other math we had here, or not math, programming. We can skip that one. That one's not necessary. I'm going to do this one. We're going to do this one. And you can see we're back to the same part we have where we have the NAs. And the reason I had to do that is because if I don't re-import the data, again, the data's been changed. It's permanent. It's permanent in memory, not permanent in necessarily the original file. So now what I'm going to do is I'm going to do a backfill. And again, I want you to focus on these right here, because this was done with a forward fill. Now let's see what happens with a backfill. If I am correct, let's take a look at the original data. I guess it would have been up a little bit more. It's going to get backfilled with the 220. So let's see that in action. And where's that line? There. Okay. So there we go. We got the 220 and the 4,354. 4,354, yeah. We had it backfilled to the NA space. Again, these are different ways to clean your data. I'll be honest, personally me, I don't feel comfortable doing this because again, I feel like I've introduced erroneous data now. I would much rather just simply drop it. If something is missing data, just drop it. Because if you drop it, it's neither benefiting or hurting your model. So let's go back to our original presentation. So as we mentioned, our models, our analysis are only as good as the data that we use. So we will have to spend some time looking at our data, making sure that it's clean, it's not missing data, that data is not erroneous. Again, we didn't talk about an instance where the data is just wrong. It's not that it's the wrong type, it's just plain wrong. That's a little harder to spot, and I would say that's application dependent. But in any case, hopefully you feel empowered that now you can clean up your data. Enjoy.